Hey guys, today we're going to talk about normal distributions, how they're made up, and how we can use them to solve some problems. The key to a normal distribution is that it's a distribution that is continuous, symmetric, bell-shaped, okay? So you can't use everything I'm about to show you if it's data that's skewed, okay? It has to be normal data in order for these percentages to work. Normal, symmetric data, okay? So the distribution should look pretty close to this in order for us to use this stuff is the first thing to understand, okay? Okay, so the next thing to understand is that if it is a normal distribution, meaning it's symmetric, it looks like a bell curve, it actually splits the data into certain divisions. So what I mean by that is this symbol here means that's the mean because it's perfectly symmetric, the average is in the center. Okay, that little symbol is one standard deviation. So if I take the mean and I add one standard deviation, I would be here. If I add two standard deviations, I would be here. Three, I would be here, etc. Now, there are certain percentages that always apply to normal distributions that we can use to solve problems. So that is that 34% of the data falls within the mean and one standard deviation above that. And then another 34% is going to fall between the mean and one standard deviation below that. Which, if we look at what that means, that tells us that 68% of the data falls within one standard deviation from the mean, okay? Because we have one standard deviation above and one below. Okay, the next division then is within two standard deviations of the mean, okay? So when we go to two standard deviations of the mean, now this next one carries a 13.5% here and a 13.5% here between the one and two different standard deviations. When we add all of those up, the 13, 34, 34, 13 and a half, we find out that 95% of the data falls within two standard deviations of the mean. Like I said, this applies for every normal distribution. Okay, the next section then we can label 2.35 every time. And if we add up all of those, we're going to find that 99.7% of the data is within three standard deviations of the mean. Okay, and then these two little pieces on the outside, where you're more than three above or more than three below, is just 0.15% of the data. Okay, so that's the basics of how it splits. We're going to use that a little bit. First, though, let's go ahead of what we mean by a normal curve. We mean that the curve is symmetrical. I mean that the mean occurs at the center. It's the axis of symmetry. The score that occurs the most frequently, okay, and it is the middle score. Okay, those are all characteristics of a normal curve. But just know, this only applies for a normal curve. So now, if we do these, we're going to look at some examples. It says, give the percent of the area under the normal curve by the shaded region. So I can look at this. One way to do this is say, oh, it's half, so it's going to be 50%. But the other way is I can take those percentages and I can fill it in and I can add them up because those percentages are going to be the same every time. So the first one to the left of the mean is 34, 13 and a half, 2.35, 0.15. Eventually you're going to know those by heart. Add them all up, you get 50%. Okay, here the shaded part is these two little ones. So again, this would be 34. You're going to know these by heart. 13 and a half, 2.35, 0.15. I just add the 2.35 and the 0.15 that are shaded, and I get 2.5% of the area. Okay. Here, I go ahead and I fill them out. 34, 13 and a half isn't shaded, 2.35. Coming this way, this would be 34, 13 and a half, 2.35, 0.15. If I add those all up, I get 50%, which makes sense because, you know, I could move this one over here and this one over here and it is half. Okay, so that's just the area under the curve. Okay, looking at this next one, okay, we're going to start using this to say what percent of the data are randomly, or the probability the randomly selected student got a score is. So let's say Mrs. Komar gave a math test to her Algebra 2 class. The class average was 87 and the standard deviation was 3. So the first thing I want you to do every time is I want you to draw. That's why I give you these. So the average, the mean, goes in the middle, 87. Okay, then I'm going to take the standard deviation they gave me and I'm actually going to add that. So 87 plus 3 puts me at 90. Add 3 again, 93. Add 3 again, 96. That would be 3 standard deviations above the mean. Okay, then I go below. So now I'm subtracting the standard deviation. 87 minus 3 gives me 84. Minus 3 again, 81. Minus 3 again, 78. That would be 3 standard deviations below. Okay, so now when it says, find the probability that a randomly selected student got a score of at least 87. I come here and I say, oh, well, at least means everything above it. That's going to be 50% of my data. Okay, between 81 and 87. Okay, so I can go and I can write those percents in that I said you're going to memorize. Okay, and I say, oh, 34, 34, 13.5, 13.5. Okay, but if I just add the between 81 and 87, I would be adding this 13.5 and this 34, and I get 47.5. So there's a 47.5% chance that if I randomly grabbed a student, they would be between those scores. Okay, less than 78. Well, that last little one, if I were to fill it in, is 0.15%. Between 90 and 93, I filled that one in. That was 13.5%. Okay. All right, another example like that. Here we go. So, mean of 100 goes here. Then I start adding my standard deviations to get 3 above, and I start subtracting and labeling to get 3 below, and then I just look. It says, I would expect 68% of the population to have an IQ between what two values? Well, that's going to be within 1 standard deviation, so that's going to be between 85 and 115 if you look at my labeling. I expect 95% to have an IQ between what, that should say 2 values. And I say, oh, well, 95%, if you come back up here, was 2 standard deviations. So I say, okay, that would be 70 to 130. And I expect 0.15% of the population to have an IQ below what value? Well, that's this outer part, so it would have to be below 55. Okay. I think, yes. Let's go ahead and keep looking at the next example. It says a normal distribution of data has a mean of 34 and a standard deviation of 5. It's already got our graph labeled for us, 34, they went up and down 5. It says find the probability that a random value is greater than 24. That is, the probability that x is greater than 24. So I know above here is 50%, so I just wrote that as this first 50. And then I went ahead and I filled in these values. So that's my 34, that's my 13.5. I added up 97.5% chance. Okay. This next one, the heights of 1,800 teenagers are normally distributed with a mean of 66 and a standard deviation of 2. So I came over here to this one they nicely provided me, and I said, okay, here's my mean of 66, goes in the middle, and then I move up my standard deviation of 2 and down my standard deviation of 2. I can fill in my percents. But if it's between 62 and 70, that's within 2 standard deviations of the mean. That's 95% of my data every time. Okay, what is the probability that a teenager selected at random has a height greater than 68? So again, I can just add those percents. So I said, okay, here's 13.5, 2.35, 0.15. That's going to give me 16%. Okay, I'm going to stop this video here because you might want a break and it's getting long. And then we'll talk about z-scores in a separate video. Sound great? Okay, bye.